Okay, this is the final video from this very long Unit 2 looking at electrons and periodic trends. We're going to look at the reactivity of alkali metals and the trend in reactivity associated with that low ionization energy. The larger the radius of an atom, the easier it is to pluck that electron off, or the easier it is for another element to come in and grab that electron and remove it and to turn it into an ion. And the easier it is, the faster that reaction will occur. So you're going to see that these different elements are going to react more vigorously as the radius gets larger. Remember, ionization energy increases as you go up, or another way of looking at it is it decreases as you go down, and the lower the ionization energy, the more rapidly the reaction will occur because it's just easier for other elements to come and take their electrons. So when you take some of these metals, these alkali metals, and you add them to water, the ionization energy is so low that the oxygen atoms in the water molecules can literally strip the electrons away. So these metals are so reactive, they react in water. So in this case, what will happen is the oxygen will basically kick the hydrogen out and replace it with the metal. So when alkali metals react with water, they replace one of the hydrogens in the water molecule. So here's a chemical reaction. Two sodium atoms will react with two of the hydrogens from waters to become two sodium hydroxides plus hydrogen gas, H2. The sodium comes in, kicks the hydrogen out, and your overall net reaction is two sodium metals, that S means solid, plus two water molecules, the L means liquid, becomes two sodium hydroxides plus hydrogen gas. So when you add these metals to water, you will see the gas bubbling, the hydrogen being produced by that reaction. So first, what you're going to see is the hydrogen gas being generated as the metal replaces the hydrogen and kicks the hydrogen out. It's also going to release a lot of heat. And as it releases that heat, the heat can get high enough that it'll actually ignite the hydrogen gas with oxygen in the atmosphere to make more water molecules. But with the chemical reaction that's igniting hydrogen gas, you get fire. Let's take a look.
Oops. Taylor can be the closest, but let's back up, everyone.
Lucky me.
Whatever direction. No, I mean actually back up a little.
I want a cave thing.
I did!
Okay, whatever direction the smoke starts going, you need to go the other way, okay? Because we don't want to breathe that in. Taylor, you're still too close, and everyone else needs to take two big steps back more. Okay, ready?
Oh, smoke's coming to the fence.
I don't even know which way it's going. Boom!
It's ignited the hydrogen gas.
That was awesome!
So what you saw there was I added a piece of sodium metal to the water. You may have heard the fizzing as the hydrogen gas was being generated. Eventually you saw a flame form as the hydrogen gas ignited under the heat of the reaction, and then enough of it was generated that it actually exploded out of the water. Let's see what happens if you add a little bit bigger chunk of sodium to water.
No, I'm not
Tell which way is the smoke going, because I can't tell on this camera. Huge.
Okay.
It's going the other way. Oh my!
So there was a reaction. Now, that's with some small chunks of sodium. Let's see what happens if we go even bigger.
That's sodium, dude. A little bit of sodium over there.
That white smoke that you see there, that's the sodium hydroxide that was being produced by replacing water with sodium in the water molecule. And then here's our final video. In
20,000 pounds of highly dangerous metallic sodium head for destruction in Lake Lenoir, Washington. The government surplus chemical ignites and explodes when wet. The alkali lake is devoid of fish and forms an admirable disposal spot. A 3,500-pound container of sodium hurtles into the lake and crashes through a foot of ice. As the water seeps in, smoke rises through a series of muffled explosions. The acrid clouds billow several thousand feet over the steep sides of the lake. Disposal of the chemical by the War Assets Administration is made necessary because no public carrier will accept it for transportation to a purchaser. One after another, with varying effects, the containers go up with spectacular results as water and sodium meet. A once lethal war chemical becomes a peacetime pyrotechnic display.
Whether you've left school or you're still at school, you can appreciate the sheer fun and mayhem that chemistry can be. There's so much to it. Bunsen burners, mixing chemicals. Very nice. Now, you may have been allowed to mix very small amounts of lithium with water. You may, if with a responsible adult, have mixed H2O with sodium. And you may, under very strict scientific control, have witnessed potassium mixed with water. But the odds are, if you have, it will only ever have been on one of those rubbish science videos. There you go, mate, present. These next two are the dog's nuts of the periodic table. They are, if you like, the king and queen of alkali metals. Mix these babies with water, stand well back, and watch the mayhem. And that's just what we're going to do. Mr. Tickle, bring on the rubidium.
Here it is.
Is that it?
Well, it might not look like much, Richard, but it's a highly reactive metal. It's sealed in this glass tube under argon atmosphere conditions, just for safety.
Right, so what's going to happen when you drop that in the water?
Well, imagine, if you will, letting off a hand grenade in a bathtub.
Righto, I'm off. Have that.
Okay.
Good luck. Okay, Tickle. Drop the rubidium in the water.
Stand back, everybody. This one's going to be bad.
2 grams of rubidium will only react when our specially designed vial dissolves in the water, which gives John a few crucial seconds to get into our safety zone. Yes!
Wow.
That is more like it. Only on Brainiac do you get that kind of science. But I believe we can go one better. There is one more alkali metal we can legally use.
Yes, Richard, cesium, the emperor of alkali metals, particularly nasty, could go off at any time.
And that's it.
Oh, yes.
Brilliant. I like it already. Now, what's that going to do when it hits the water?
Imagine a depth charge in a bathtub.
Fair enough, mate. I'll leave you to it. Good luck.
Thank you.
Okay, John. Go for it.
Warning, 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 extreme danger, clear the area.
As our cesium sinks in the water, the rapid generation of hydrogen gas should produce quite an explosion. And it does. magnificent. And I think that concludes today's experiment. There is, I should say, one more, even more reactive metal, francium. But for some reason, they wouldn't let us have any of that. Still, there you go. Today's lesson.
Never mixed alkali metals with water.
All right. It's worth noting there is not any francium available to do that because it's a radioactive element whose half-life is only 7 minutes. So if you ever go on YouTube and look up explosions of francium, they're all fake.